Hey everybody. So what I'm going to attempt to do here is I'm going to attempt to modify my print bed on my X3 to give me a little bit bigger print area. My height's going to stay the same, but I'm looking at going from 220 on my X-axis up to 250, 255, and I'm looking to get from 220 upwards of 300 on my Y-axis. So the first thing I'm going to do is I'm going to remove my whole bed assembly from the printer. Then I'm going to loosen up my brackets here holding my motors, and these can drop. And I'm going to need to do that for what I want to do. First off, just to give you an idea of what I'm at and what I plan on going to. So here's my aluminum heat bed, and I had this mirror on top of it. And now my print area was in this area here. There's a bezel there, so it's just the area inside the bezel. So I was getting about 230 by 230. But this bed here will only allow me 220 by 220 total edge to edge. I plan on going from, this will stay, my heated bed, but what I plan on doing, and I'll probably lose 1 or 2 mil print height, but that's okay, is I plan on increasing my print bed size from this to this. So just to give you a comparison here of the two, this is what I have before, this is what I'm looking to have when I'm done. There'll be 2 parts to this modification. The first part is going to be hardware, then the second part will be software, where I have to go into the repetier software, firmware, and modify my parameters for the size of my print bed, because right now with the repetier software, if I try to go above the 220, or well, I have it at 230, the 230 mark, it will not go above that point no matter what I do. So I have some residual tape here on the bed that I'll have to remove, but I'll do that later off camera. For now, we're just going to disassemble the front of our Y-axis so I can remove the bed from. Let's turn this around so you can get a better view of what I'm doing. First thing I'm going to do is I'm going to want to remove my my assembly here so I can pull this right off. Okay, just so that I don't have to measure this again later, I'm just going to tape where my corner bracket is located here to make it easier to find later, that position. I'll set that off to the side. This in, take the belt off. Set that off to the side as well. And we're going to have to disconnect our belt. And we're just going to set this right there out of the way. And we'll set our springs aside. Okay. Dusty. Now, this belt. So I'm going to have to take these zip ties off and remove my belt. Now we can just pop this right off. And we can move the printer out of the way. So, first thing I'm going to do is I added this little printed bracket here because originally my bed would go too far back and my hot end would be sticking out about 1 inch past the bed. But since I'm increasing my bed size, I want that inch. So I'm going to remove that. But that's only going to give me another inch. Second thing I'm going to have to do to get that other 30 is I'm going to do a second set of holes for these wheels. I'm going to go in about 15 mil on either side. I'll test it out for stability to make sure it works. But I can't see why it wouldn't. They'll only bring them in this far, so we'll see. See how that works. So give me a second here. So the two key things I'm going to do are, firstly, I'm going to move these wheels in about 10 or 15 mil in, and that should give me pretty much 300 mil on the y-axis. Second thing I'm going to do is the brackets for the z-axis stepper motors. They have slots in them, so these can be adjusted down or up. I'm going to adjust those down so that I have better clearance for my bed above the coupler, and the distance between the two couplers is about 262, and I'm going to go for a distance of 255 in between the two couplers for my x-axis. And that'll be pretty much the limit of my x-axis, unless I want to do some serious modifications on these two stepper motors, the brackets and those threaded rods, as well as the brackets here. And this is just a basic mod. I'm not going to go into re-engineering this thing. This is something that you can do on the cheap easily yourself. Just get yourself a piece of aluminum cut 3 mil thick to match it. That'll go on the aluminum heat bed, because it is aluminum. It'll conduct the heat well, and it'll spread it across the surface. And then, after, if you want, you can throw a piece of glass down on that to make sure it's flat and level. So, but this will be the biggest simple mod that you could do. What I want to do is I want to draw a straight line in this direction at the center point of these holes. So, and then I'm going to measure in. I'm going to go 10 mil. That'll give me 20 plus the 25 from removing that bracket, and then I already have 250 mil plate, so that'll be about 295. Yeah, let's see how this looks. Be nice to have a pen that works. So theoretically, when I come forward, because my wheels are going to hit this bracket, because I've moved them back, I should get another 15 millimeter of travel here. And same on the back. Before, I had this bracket here hitting the end stop. Without this bracket there, this back wheel will hit the end stop. Moving it this way, I'll get another 15 millimeter in travel in that direction. So a total of 30. And then taking this off the bed will give me another 20-25. So that, with the fact that I already had 250 millimeter of play, should give me around the 300 mark I'm looking for. So now I got to get a bit to drill these holes. So let me take my calipers here and see what I'm looking for. So the hole is 5 millimeter in diameter, this hole here. So I need to find myself a 5 millimeter bit. For anybody who wants the imperial version of this, it's 200 thou in inches. 200 thou. Okay. So I got a sacrificial piece of wood here so I don't damage my table. And we have 197 thou, so 200 thou bit. And we have a couple of smaller bits that we can use for our pilot bits, just in case. So we have to be very careful here and take our time as to not crack the acrylic. Okay, so just so we can see that there are my pilot holes, right there. And now I'm going to drill my 200 thou holes. So I want to be very careful with this bit, because now that I have my pilot hole, if I rush this or force this, I'll end up grabbing the acrylic and splitting or cracking it. And then I'm further back than square one. See what I mean by grabbing? It wants to tear at it. And I'm actually glad I left this protective back on, because it'll actually reinforce the acrylic that's there. Okay, so there's one. Not perfect, but good enough. So 3 more very iffy holes to drill. And no matter how much force I put down on there, that wanted to lift up. So they're not perfect, but we'll see if they do. Look, if they'll make do. So next step is to put our wheels back in place. Now let's see if this goes back on here. Okay, come here you. Should be a little force. Let's see. Let's loosen them up here. Might have went a little too far. Get on there. Should go on there now. Just be careful you don't cut yourself. So just gotta tighten those up now. Okay, so that's that back in place, the bed. I have my side to side's good, everything's good. So I just got to tighten these up underneath, and it should be good to go there. Let's get the screwdriver in place. Actually, before I do anything, let's put this guy back on. So far so good. My side to side is still the same as it was before, and I don't have any ill side effects from bringing them in closer. And now I can actually come out a lot farther. You'll see my wheels are hitting right there, so my nozzle is right back here. So we can go ahead and put our belt back through. Okay, now I need to just get a couple of zip tie that back up. I can install my front pulley assembly back in place. Throw my heat bed back on, and then the next step is to lower these 2 brackets down so I can get clearance above here. So I wanted to do this mod for a while now. The reason why I wanted to do this mod, but I wanted to wait until I got at least one of the other 2 printers I ordered. I do have Delta printers here, but I wanted at least one other Cartesian style printer in here before I started messing with this printer, in case I did something to muck it up permanently. So I have my CR10 now, so I figured now's a good time as any to do this. Worst case scenario, I gotta cut another build plate, or another support plate under my heated bed. And if that's the case, I'll make one out of aluminum first. Okay, so those are back in place. So now, what we need to do is I need to move this there, out of the way. Slide this guy back on. Get my belt back over him. And that belt could have been in there a lot tighter. Or this belt. So I need to make sure my belt in the back pulley wheel is on. Yep. So I'm going to pull some of this out even further here. So I'm not hitting my end stop switch. Here, what am I hitting? That's stopping me from going further. I'm hitting my bracket. I'm hitting right here. That sucks. So this stupid angle right here is causing me to lose 5 mil. That extra 5 millimeter right there, maybe 5 to 10. I suppose I could Dremel that out, but I risk cracking that acrylic. Okay, so what I'm doing is I'm taking a small hacksaw and I'm going to remove this angle off of here. There we go. So that takes that angle off. Let's see if we trigger our end stop now. So I'm going to have to do something. This is going to catch there now. Still not catching. So how much further? We're close. We're so close. I'm talking like 3 mil. But taking that angle off gave me another 10 millimeter. So now what I'm going to do is that angle went down like that on an angle right there, and I made it square. So I'm going to come back here and do my angle again so that I don't catch my cable for my heated bed, which you'll notice I got triple shrink wrapped on here so that this thing stays durable. So let's go on a nice 45 here, and I can just sand the edge smooth there. Snap right off on its own. Clean that up. Clean that up. Now let's see if we hear the click, the satisfying click of an end stop being triggered. There, look at that. So I'm pretty certain that that gave me another 10 mil. So I'm going to check that now. Get me ever so close to my 300 target. So we're pretty far back there from the hot end. The hot end's right there, the nozzle tip itself. So let's check that with the calipers. And we're looking at, let's straighten up here, 40 millimeter. So I've got 40 millimeter increase here, and in the front, as I said, I'm looking at, I got an inch in the front, so 25. So 40, 50, 60, 65 millimeter increase above my 220. That gives me 285. So that looks like the limit of what I'm going to be able to get without having to do anything drastic, anything else to this printer. I'm going to have to clean this piece of acrylic up. Now that I got that angle back there, it doesn't look like it's going to catch. It looks like it's going to move smooth. But it looks like the most I'm going to achieve here is about 285 in my Y direction, which is still a 65 millimeter gain, which is pretty good. But I'm satisfied with that. It's not my 300 mark that I'm shooting for, but it's still a 65 millimeter gain overall in my y-axis with a few simple mods to what we already have. Next I'm going to adjust these brackets lower. I want to clear my I want my bed to clear above my couplers, because I want this bed that I've gotten cut for me, this new piece of aluminum, as you can tell, is quite wider than the 220 that's already there. This thing is 255, but that is just the distance between the two couplers, just the distance. So I want to lower these motors, and I don't need these threaded rods to go all the way to the top, because these wheels are going to hit here long before my my bracket here ever gets to the top. I've got almost an inch here of play up there, so I could drop these down about 3/4 of an inch, have lots of clearance for this to slide through, and it wouldn't affect my height. The only thing that's going to affect my height is the thickness of this aluminum plate, which is about 3 millimeter. And as I said, I'm going to throw a piece of glass on it anyway, which I already had on here. Even with the 5 millimeter mirrored bed on here, I still had a print height of 300. So that will be my next step. I'm going to scribe a line with my calipers. For anybody out there that don't have calipers, you can do it by any other means. I'm going to scribe a line with my calipers and line it up using that line. So when I say scribe line, I'm going to take my calipers and I want to lower these about 2/3 of an inch, so, or about 15 millimeters. So I'm going to take my calipers and set them at 15. I'm going to scribe my line. Okay, let me bring these in here for a close-up of this. So what I did is, if you see there, I scribed a straight line, and I'm going to use that, flush that up against the bottom here to make sure that this is perfectly level with the frame, so that I get no funky issues with my threaded rod. I've had no issues so far with my threaded rods. They've been very straight and very smooth. Now I don't know after today. I'll go modify the other side. I cleaned off the two-sided tape as best as I can off the heated bed. I'm no longer going to need this mirror. I'll set it aside, maybe for another project. I have a ANET A2 Plus coming someday from GearBest. I don't know when, but in the meantime, I'll just put it away for now. So first thing I'm going to do is I need to figure out my spacing for this build plate on the heated bed. So I'm 255 millimeter across my x-axis, where I'm 220 here, so that's 35 millimeter difference. Divide that in two to split the difference, and I got 17 and a half. So I'm going to take my calipers and put them up to 17 and a half, and I'm going to scribe a line on the back side of this. I got some two-sided 3M tape here that's going to hold this aluminum plate to this aluminum plate. So we'll take that and scribe that line. figure out how far back. So when I moved this to the back the last time, take this tape off now. When I moved it to the back the last time, my distance from here to there was 40 millimeter. So I'm gonna I know I got an extra 15 millimeter plate on this bed because it's 305 long. So I'm gonna bring the bed out 50 in the front so that I know I have more than enough space. So we're gonna take the calipers and we're gonna set them out to 50 now. We're going to scribe a line. And that's roughly where this bed will fall into play. This is going to be, we have to be careful here. So I want to make sure that everything lines up perfect. You could even probably take some spacers here to ensure, at least along two edges. I think that's actually something I'm going to do here. So I just happen to have some wooden blocks lying around my shop. So I'm just going to line them up and two-side them taped down. I'm just going to line them up and use some two-sided tape, just a few pieces to hold them in place, and then remove them when I'm done. Okay, so this will go, basically we'll use the boards to drop that down in place, and then just test out that that's where we want it. Just for reference sake, this is the heated bed, which is 220 by 220. And this is the upgrade I plan on doing. Get an idea of the difference this way. Get an idea of the difference this way. Okay, so we're almost ready for the software. These are going smooth now. And now we're going to put some two-sided tape down on this bed. It looks huge on there. Now I can pop these pieces of wood off. Tape's stuck to the bed, so on the other side of this I'm going to have to pull those small pieces off. No big deal. That's why I only use small tabs for the wood. Now the front. As I was saying, I've had a few people on the Facebook page for the X3, as well as the CR10, and a few of my videos on YouTube ask me about leveling the bed. Everybody's going on about auto bed leveling sensors and whatnot, but I think those are absolutely unnecessary. unless you're moving your printer around a lot and you're constantly doing things to your hot end or whatever. The only time I ever have to re-level a bed is if I'm playing with the nozzle, replacing the nozzle. I move the printer around, or I'm doing something stupid where I jar the printer, or I accidentally turn one of my threaded rods when the steppers are unlocked, and then I throw my gantry out of balance with the bed. It's no longer parallel. So maybe after this video, when I go to level this bed, I'll film that and I'll throw that up on YouTube as a quick video on how to manually level the bed. I don't know if anybody's interested in that, as I said, it's a pretty simple process. Okay, so that is it for that. That is the hardware aspect of it and modifying it. It's a much bigger area now. Camera down so we can appreciate that, but right from this view alone we can see how big that is. Be nice if I had another X3 next to this one so I could show before and after, but I think from this view right here you get an idea of just how big that bed is, right? And it's just a simple upgrade. Like, I didn't do a whole lot. I modified the acrylic plate underneath, and it didn't cause any issues forward backwards wise. It still has the same amount of side to side play as it had before, and that's only because it's on 2020 extrusion, not 2040. I dropped my stepper motors here so that I could get clearance here. Let's take you here on a little tour so I could get clearance there, so you see that. Otherwise I wouldn't have that clearance. Drop those down by a little over about 22 millimeter. That was enough so that I still have adjustment on my bed. Did that to both sides. They're both down just as far. It's just one side happens to have the screws for the springs tightened a little more than the other right now. And then we modified our acrylic plate, so we moved our holes, and that gave us another 30 millimeter there. Plus we already had a wasted 30 millimeter to begin with, so the two of those together gave me over 60. So I got an extra 65. Plus I modified a little modification here, if you can see that. So this originally was here and came up on an angle and went back. So I just took a small hacksaw. I can clean that up later on, but I think it's fine the way it is. And was able to move that back. And probably if I wanted to modify this bracket, what I'm thinking is if I wanted to make a modified version of this bracket, I could probably move this stepper limit switch back here somewhere, right about there, and that would get me to my 300. But for now, I'm about 285. I'm happy with that for now. It's still not my goal yet, but you know, maybe a redesign of this bracket, print a new one out, and then I could maybe instead of mounting it here, mount it on here, right? Just a bracket there, mount this here, and still has the same effect, and then I could have the same bracket mount this back here, right? And then the switch, I can't mount the switch farther back than here. This switch would have to be triggered right about there, or else I end up hitting this anyway. The next step in this now is modify the firmware and set my new limits for my X and Y axis. I'm probably going to set a limit for my Z axis so I don't by mistake forget that and pop off the top. I'm probably going to put that at 295. Okay, now that we're all finished with the hardware modification, we can move on to the firmware. The first thing I need to do is install an older version of the Arduino IDE, because I'm running repetier 0.91 on this printer. When I try to upload that firmware using a current version of the Arduino software, I get compile errors. Now, there are several links here that I will be putting in the description, all of which are relevant to this situation. The first will be this link here, which is the link to the older Arduino software that we want to install. Now, if you go to the wiki page for the X3, it's going to give you some instructions here on how to install this firmware. This might be the case for the Marlin firmware, but I know for the repetier firmware there are two issues here. One, number 4 here, the latest version of Arduino IDE will not work. Two, the link here to this version of Sanguino, if you download the Sanguino master package and then you upload the firmware, it will look like it uploads to the printer, but really nothing takes. So I'm going to go over the two solutions here right now. The first solution, number 4, is download and install Arduino 1.0.6. The second step would be, once that's done, is you're going to go and you're going to take this link that will be in the description, and you're going to download and install this version, or download this version of Sanguino. Once you've downloaded this, you're going to go to your, once you've downloaded the Sanguino zip file, you're going to go to your downloads folder, you're going to open the zip file, and you're going to have this folder inside. What you want to do with that is you want to take it and you want to copy it into the hardware folder for your Arduino software. So I have the Arduino software installed in under my program files, and I want to copy that zip or that Sanguino folder into this hardware folder, as you can see right here. Well, once you've done that, there's nothing else there that you need to do. Then, when you open the Arduino software, you're going to see here under Tools and Board, you're going to have the option for Sanguino. You're going to want to select Sanguino at Mega 1284p 16 megahertz. Then you're going to want to select your serial port. I don't have the printer hooked up right now, but if I did, I'd see another port option here. Then you're going to open up the version of repetier software for your printer. That you're going to find on the wiki page. I'll put a link to it. But this is what you're going to want to download right here. And you're going to unzip that file. And then in your Arduino software, you're going to locate the repetier file with the little Arduino symbol next to it. You're going to open it. And that's going to give us access to the firmware. Now we're going to want to go to configuration.h. And if we scroll down a little ways, we're going to get to our max length settings for X, Y, and Z. Now there's an issue here which I'll get to in a minute, but we're going to change these to what I was able to accomplish with my physical hardware mod, and then I'm going to go down here a little further because there's a couple other things I want to change. I don't like the preheat bed temperature for the PLA, so I'm going to change that to 60. Currently in the software it's set to 55, but I always end up putting it up to 60, so I'm going to change that to 60. Plus, with the extra aluminum plate on there, I'm going to need that little bit of extra heat. I also changed my boot up display on the printer, so whatever you want there. And then what you're going to do when you're done with all your changes, you're going to verify that everything's okay, and if everything's okay, you're going to click the this little arrow key here, and it'll upload the firmware to the printer. There's going to be, it'll get to 95% fast, and it's going to look like it hangs, but you just leave it and bear with it. It will complete. Once it's complete, the printer will reboot. You'll see the changes in your boot up if you've made changes there, and you'll see the change for your preheat PLA bed temperature. However, you will not see the changes for your max X, Y, and Z. And this really stumped me. And then Chris Bennett on the Facebook group page offered to lend a second set of eyes, and with his help he managed to stumble upon a forum topic on the repetier website itself, going on about the very problem I was having. And after reading through this, what I came to understand is that the max limits for your X, Y, and Z are also included in the EEPROM. especially for your repetier firmware on the printer. If you change these in the firmware and upload it to the printer, the EEPROM takes precedent over this. So no matter what you do in the firmware, the numbers in the EEPROM will remain the same, and the printer will take those in priority over any changes you've made in regards to those three numbers. So what you'll have to do now, it's pretty easy once you figure that step out. Once that's figured out, what one has to do now is you have to download and install a repetier host. And once you have, let me open that up. There we go. So once you have repetier host running, you connect to the printer. Once you're connected, this little grayed out option here will become selectable. And when we select that, we get access to all the settings in the EEPROM. And then there we can change our max limits for our length on our X, Y, and Z axis. We click OK, and that changes them in the EEPROM on the printer. Another benefit to this is we can also export and save all our settings in the EEPROM on the printer to our computer, so that if anything happens on the printer in the future, we can always import those settings back in. So with that said, the firmware on the printer is now been modified and good to go. So the next step in this process will be to level the bed and do our test print. So here's our jumper. I have it set up so that the printer can write to the board. So I'm all done there. Now I'm going to flip this back to normal and put my cover back on. And then we're going to okay, now that we're done with our firmware and we're ready to proceed with leveling the bed, I'd like to thank Chris Bennett for helping me out there with the firmware, because I was at a loss until he found a post online mentioning certain settings are locked in the EEPROM for the repetier firmware on the printer, mainly the X, Y, and Z limits on their axis. So I had to install repetier host and access the EEPROM through there, and I was able to change those settings. First thing I'm going to do with this printer is I'm going to make sure my bed is relatively parallel to my gantry. So I'm going to go over here and I'm going to take a measurement here. I have 31 mil, and here I am just under 31 mil. So I'm going to want to increase that. So now I'm at 31 millimeter. So you want to do that while your stepper motors are not locked. The minute you lock your stepper motors, you're not going to be able to fine tune your thread rods. So all I did there was turn this rod a little bit to ensure my gantry was parallel. Another thing I did off camera was I readjusted my X end stop here so that I was in a proximity to my corner here, and then I just fine-tuned my thumb screw here until I was able to just catch a folded piece of paper underneath. Even that is a little loose. What you want to do here is you want to fold a piece of paper in two, which will be about 11th thou, and you want it to just start catching. I'm going to have to redo this process eventually when I get a piece of glass for the bed, but at the moment I don't have a piece of glass. One important step that should be taken when manually leveling your bed is you should bring the bed up to temperature. So I'm going to bring the bed up to 60 degrees Celsius, and then we're going to come back to the printer once it's hit temperature, and then we're going to check all 5 points, center and 4 end points. Now this piece of aluminum I know is not perfectly flat, especially given its size, but my intentions are to put a piece of glass on top of this, which will be perfectly flat. But for the meantime, for the purpose of this video, is just to illustrate how the process of it is going to take a little bit longer to reach temperature than before, and that is because I have this 3mm aluminum plate on top of the other aluminum plate. And for anybody that has a question about well, this extra area out here, will it heat up or will it stay cold? Yes, it will heat up, because aluminum is a perfect heat conductor, and because the two of them I have double-sided taped together, the heat transfer from this plate will spread evenly through this plate. The temperature from the center might be a little warmer than the edges, but it won't be too much. We're talking like 2 or 3 degrees, as the temperature will spread out evenly across the bed. So this is going to take a little while. It's probably going to take 4 or 5 minutes longer than normal to heat that bed up, because I got a lot bigger surface area now to heat up. So we'll get back to this. So the bed is heated up, and we're going to rehome everything. And we're going to check to see if we're still snag catching here. We are. We're just a little bit, so I'm going to adjust this out a little bit more. I want this to catch a little better than that. Okay. Now we're going to move over to the front right. See, so we can see this. There we are. So we're going to move over to the front right, but first we're going to raise our Z-axis 2mm, and then we're going to move over to the front right corner. Okay, right about there. We're going to put our paper under there. So we actually have to loosen this. And now we're catching. There we are. Just a little bit more. There, we're just catching our paper there now. Okay, there we go. Okay, so now we're going to go to the back right corner. And there is 285. So now we're going to put our piece of paper here. We're going to go back. We're going to drop our Z-axis, and we're going to see how much adjustment we need at that thumb screw. So we're going to need some adjustment there as well. Okay, so that's good. We're just starting to catch. We can still put our paper out and under. So now I'm a little over. I should be able to just catch my paper underneath. Perfect. So next, we're going to raise our Z-axis. And then we're going to go to this back left corner. This is good enough. And we're going to lower our Z-axis. We'll get our paper positioned in there. So that's a little too tight. So we'll adjust the thumb screw. And that's what we want there. So now we're going to raise our Z-axis again, and we're going to come to relative center, just to verify our center. Now again, this aluminum plate is not perfectly flat. There we go. And now we'll take our piece of paper, our folded piece of paper, and we'll drop our Z height. And you see here I'm not really catching there like in the corners because this thing's got a little bit of a bow in it. But a piece of glass would fix that just fine. But for now I'm going to do a print to test this outer dimension. And I'll worry about that center flatness a little later once I get a piece of glass in here. Right now my bed is heated up just fine. So bear with me for a minute and we'll get a print loaded on the printer. And we'll start testing out they look almost similar now in size. I'm just short 50 mil on the x-axis of meeting the CR10's bed size. Here's our finished test piece. We'll just pull the bed out a little bit here. Seems to come out pretty good. Overall, that test piece came out pretty good. Get this back in focus here. Let's measure this. Grab a tape measure. Get that on the edge. Make sure. Let's get this camera stand out of the way. We got that right there. $248, $249, and then we'll hook it right there. Let's see, we have. Hold on. There we go. 277, 278. That's pretty good. So that's